What is a probability distribution in statistics? The probability distribution gives the possibility of each outcome of a random experiment. It provides the probabilities of different possible occurrences. Why we need to study probability distributions. Probability distributions help to model our world, enabling us to obtain estimates of the probability that a certain event may occur or estimate the variability of occurrence. They are a common way to describe, and possibly predict, the probability of an event. The binomial probability distribution is a discrete probability distribution that models the number of successes in a fixed number of independent Bernoulli trials. It is commonly used to analyze situations where there are two possible outcomes.
Probability distribution. That is, one is binomial, another one is your Poisson, and the next one is your normal distribution. Now you see, binomial means what? It's very obvious. Can you tell me what is binomial? Binomial, what do you mean by this word binomial? It means bi and nomial. Bi means two. Nomial is a polynomial. Alright, that is, if you have any polynomial in two variables which can be written in this form, is said to be a binomial. Alright. Now, in probability, how we are going to deal with this? This deals with the trial. We have already done random variable. I told you that whenever you are conducting any activity, experiment, then we call it as event or the trial. So in binomial distribution, if your trial is of repetitive nature, means their repetition is there. Repetitive nature means only one activity is getting repeated again and again, then it is considered under binomial distribution. Provided its outcome should be only of distinct nature. Its outcome should have only two possibilities. Only two possibilities. Now, can you give me the examples? Binomial distribution deals with an event or the trial which is of repetitive nature, provided it should have only two outcomes. उसके दो ही results निकलने चाहिए. That is in the form of, say suppose, true and false, yes or no, acceptance or rejection, event will occur, will not occur, will occur, will not occur, so on. If any activity का result is something like that, that gives only two answers, या तो होगा या नहीं होगा, that will be included under binomial distribution. So binomial distribution has three main properties. First is, should have n number of events. N number of events. N number of events का मतलब कि हमारे पास जो भी हम एक्टिविटी कर रहे हैं, it should happen only finite time. It should only happen finite time. That means your activity can be calculable. It should be calculable manually, or somehow it can be easily predictable. Then, and all the activities should be independent of each other. Should be finite and independent. किसी एक एक्टिविटी का दूसरे रिजल्ट पर असर नहीं होना चाहिए. So you have individual outcome. So this is the first main property. It should have n number या finite number of events, and all the events should be independent of each other. Secondly, it should have only two outcomes. उसके दो ही results होने चाहिए. And third, the probability of all trials, कि जो भी probability है of all the trials or your experiment, it should have only two results, that is P and Q. P means success and Q is failure. Success or failure. Now probability of success is denoted by with small p and probability of the failure is denoted by small q, such that the sum of probability of success and failure is always equals to 1. And your random variable is presented with capital X. The random variable means तुम क्या चाहते हो? If suppose you are tossing a coin 10 times, but I wish कि 5 times या 6 times tail आना चाहिए. So number of trials are 10, but what I am expecting tail 6 times. So my random variable or capital X is 6. Alright. Failure will be up. Coin है तो coin के 2 ही result होंगे, either head or tail. So probability of success is also 1/2 and probability of failure is also 1/2 because 1 minus 1/2 that is again 1/2. Alright. Now how will you evaluate this binomial distribution mathematically? It is evaluated as probability of your random variable, that is your capital X. We have a formula as NCR P raised to the power R and Q raised to the power N minus R, where your R, your random variable takes the values 1, 0, 1, 2 till nth item, that is nth trials. Alright, where your these N and P, these are known as the parameters. These are known as parameters. किसके? These are known as parameters of binomial distribution. Alright, these are the parameters of binomial distribution. So what you have concluded till now, binomial distribution is, it is if your number of trials or events should be finite, its outcome should have only 2 possibilities, and the probability of success is denoted with P and probability of failure is denoted with small q, such that their sum is always equals to 1. Then mathematically we evaluate probability as NCR P raised to the power R Q raised to the power N minus R, where your N and P are known as the parameters of the binomial distribution. Alright, and this R is also known as variate. We also call it as variate or binomial. Binomial में कर रहे हैं तो it is binomial variate because question में given होगा कि your variate is this, evaluate this. तो variate means वो random variable की बात कर रहा है. Alright, now one thing more, यहीं लिख देते हैं. Now, if they have asked you evaluate the mean of binomial distribution, the formula of the mean is n into small p. Your n is number of trials and p is the probability of success. And the variance is your this is square of sigma, which is n into p. Alright. So, this is your this. And you already know, अगर standard deviation पूछेगा, तो your standard deviation is what? Under root of variance, which is your sigma. That is under root of NPQ. Fine, everyone? It's clear? Alright, fine. Now next is your Poisson distribution. We will do numerical. एक साथ, fine. Now what is Poisson distribution? Why you need Poisson? Can you tell me? Poisson की जरूरत क्यों पड़ गई? Any idea? Why you need Poisson? Any rough idea? No one? So let's not waste time. You see, when you are dealing with your binomial distribution, so जो binomial की properties हैं, वो limitations हो जाएंगी. कैसे? For the Poisson, binomial can be conducted only n time. What if my trial or experiment is infinite times? If you are conducting your experiment infinite times or to a very large number which you cannot calculate manually, fine. Then in that case, we cannot apply binomial. Secondly, what if your outcomes are more than 2? Then again we cannot apply binomial. What if the probability is very small? Because in binomial, your probability is not small. We consider usually greater than 1. Not greater than 1 means it's lying from 0 to 1, but it's not nearly 0. But if your probability is nearly 0, then again binomial is not applicable. Alright, so your Poisson is applicable. Now the limitation of binomial will be the properties of your Poisson. That is, your first property will be the number of trials are infinite. N is your number of trials. First property, number of trials are infinite. We are nearly infinite. And secondly, probability of success. Your probability of success, that is small p. Probability of success, that is small p, it should be nearly 0. Alright, that it is infinitely small. Infinitely small. Yeah, infinitesimal. Infinitesimal. और इनफाइनाइटसिमल मतलब 0 प्लस. 0 प्लस मतलब 0 नहीं है लेकिन 0 के बहुत करीब है. That is your 0 plus towards the positive side. 0 negative कर ले तो it will be nearly 0 but towards negative side. So this is the probability of the success which is not 0 but nearly 0. Alright, and you see in the binomial distribution we were representing mean with mu. Binomial में we represent your mean with mu. Alright, so this is your mean. But in Poisson we represent with lambda. लेकिन mean का formula is again same. This is equals to n into p only. Alright, and binomial में variance was n into p into q. npq. और mean था np. यहाँ पर your variance is also n into p. They both are equal. Alright, these are three properties of the Poisson. This is, and where your mean is finite. Your mean is finite. Yeah, we have finite mean in Poisson distribution. Alright, so how you conclude Poisson? It has number of trials should be very large or huge or nearly infinite, and the probability of success should be nearly 0. It should have finite mean, and both mean and variance are equal in Poisson, that is equal to n into p. Now how you evaluate mathematically? Then probability of your random variable at some point x is e raised to the power minus lambda r upon r factorial, where your r is 0, 1, 2 till infinity. Okay, here your lambda is known as parameter of Poisson parameter. Binomial में क्या था? Binomial में your parameter was n into p, and in Poisson lambda is your Poisson parameter. All right, everyone, it's clear? Say yes or no, jaldi. Everyone, it's clear or not? Poisson distribution. You just need to remember this only. These are the main facts regarding your Poisson distribution. Alright, because I'm erasing the board now. Vaishali, normal distribution. Very, very interesting and very, very important because it has a huge or wide real life applications. Now, normal distribution is applied when your data is symmetrical. Matlab, if we have a central tendency, your data on the right hand side and the left hand side will be mostly equal. Alright, so what we do, Poisson and binomial में you see it's थोड़ा lengthy process. High ज़्यादा calculation है, but in normal distribution we calculate using a curve, and that is a bell-shaped curve or a normal curve, where this line represents your central tendency, that is your mean. We take this as central line and we call it as a symmetrical line. It's your symmetrical line, such that the data on the right hand side is always equals to your data on the left hand side, and the area of the region 1 and region 2 are always equal, and we denote as 0.5. We consider that area of the region 1 is 0.5 and of region 2 is again 0.5. Fine. Of course, I am speaking, Bhavna. You can't hear me. Normal distribution. So we evaluate the area below the curve. All right. And then we get our probability. Now, how you evaluate this? We apply normal distribution only when your probability of success is nearly half. मतलब 0.5 के आसपास अगर हमारी probability आ रही है, then directly हम आंसर उनसे भी निकल जाएगा, but we usually apply normal. अगर your probability is nearly half, then you will always apply normal distribution. ये shortcut है. Yeah. Value now you see this is your curve. The curve को we represent as a function f of x. So mathematically, normal distribution में your f of x is defined as 1 over sigma under root. Fine. All right. Then e raised to the power minus half, then x minus mean. Your mu is mean upon sigma, इसका whole scale, such that your x को क्या बोलते हैं? X is your random variable. Here we call it as normal variate. Normal variate. And its value lies from minus infinity to plus infinity. Alright? Minus infinity to plus infinity. You can see on curve. This is minus infinity and this side is your plus infinity. Right? Minus infinity to plus infinity. Also, your mu is also lying from minus infinity to plus infinity. And your standard deviation is strictly greater than 0. Now you see your function. 2 pi is a constant term. Sigma is your standard deviation, which should be strictly greater than 0. In the numerator also, x is your normal probability of your random variable. Mu is your mean and standard deviation. So we require only 2 elements. We need to find mean and standard deviation. If you have these 2 values, you can easily evaluate your normal distribution. But furthermore, first, okay, these are the properties. I'm telling you the properties first. Suppose first property is your function should be strictly greater than equals to 0. Your function should be greater than equals to 0 means it should be a continuous function. Alright, your function should be continuous. Second property is your integral of the function का sum. Your integral, that is, integral का मतलब क्या होता है? Sum. So integral of the function or your continuous curve, it is always equals to 1. Next, your normal distribution should be symmetrical. वो तो हमें देख कर नजर आ रहा है because we are using curve. So normal distribution is always symmetrical. कहाँ पर? Symmetrical about mean, because central line को we are representing with our mean. It is symmetrical about the mean. And your mean, median, mean and median and mod, they all coincide. Means they are intersecting at one point. Now you can see easily from your curve. कहाँ पे कंसाइड करेगा? Mod is the highest point. So this is your point where your mean, median, mod coincides. Mean, all the three F, mean, median and mod. But in practical or numerically, we don't apply this X formula. We convert अपना X into standard normal distribution. कैसे? We convert X को into Z. तो Z का formula is capital X minus mean upon standard deviation. Alright, now Z is known as standard normal variate such that कि हमारी mu की value is always 0 and standard deviation, that is your sigma, this is always equals to 1. So जब इसको Z में convert कर दोगे, everything will be same. Your X will be replaced with Z, your mu will be replaced with 0 because mean की value कितनी होती है? 0 होती है. Alright, and then your function f of x is converted into 1 over under root 2 pi remains the same because it's a constant term, and this is e raised to the power minus half z square. Z is your standard normal variate. Fine. This is your normal distribution. बस इतना ही याद रखना है. Normal distribution is applied when your probability of success is nearly half. Fine. Your formula for f of x is given in this form where mu is mean, sigma is your standard deviation. Function should be greater than equals to 0 and it should be a continuous function. Integral की value is always equals to 1. Your curve, that is normal curve, should be a symmetrical curve such that your mean, median, mod should be coinciding at the highest point. And we use standard normal distribution. For that, you have to convert your x into a normal variate. That is in terms of z, which is given by x minus mu over sigma, such that fz is equals to 1 over under root 2 pi e raised to power minus 1 by 2 z square, where your mean will be 0 and standard deviation will be 1. Alright, everyone, it's clear? Now we'll do question. बस इतना ही था तुम्हारा normal तुम्हारा probability distribution. Can we come to the question now?